So I am from the University of California, Riverside. I'm working on my doctorate, and today I will present the presentation titled Unraveling the Mysteries of Ibervillea sonorae, a phenom of Mexican traditional medicine. So the genus Ibervillea is distributed all around Mexico. You can see this distribution map ranging all the way down to the Yucatan and even a species in Guatemala in the jungle, up to the dry Sonoran Desert and Chihuahuan Desert in Mexico and the American Southwest. And but the most commonly cited species for herbal medicine, even for species sold in central Mexico or around, is always attributed to Ibervillea sonorae. And the specific epithet sonorae indicates just that, the species from the Sonoran Desert. The green and teal here. It's debatable if green and teal are the same species, and that's the species I'm working with. So what is this plant? This is a cucurbit. So in the summer, after the August rains, it produces a little melon with people, and with these five-parted flowers. So interestingly, there's both male and female plants. It's dioecious, and of course cucurbitaceae. But it's not the melon that they use, like you would think of a squash or something like that. That actually dies off quite fast. It's only green for about 4 to 6 weeks after the summer rains. And the medicinal part is this enlarged caudix. So a large stem portion of the plant is termed the caudix. And it really just looks like a stone. So actually I've been going through the what they call thorn scrub there. And I'm like, oh man, I'm looking for my plant and it just saw a stone. And then I look again, and it was my plant of interest. So it's highly mimetic. It blends into the what they call desert pavement. And it is sold along roadsides in herbal markets. There's quite a high demand for it to treat diabetes. Diabetes being an increasingly strong threat to public health in Mexico, actually the whole world, but especially the rate is even greater in Mexico. And so people here sell this plant, make a living. It's extracted from the natural environment and ingested by humans. So our main question is, how is it actually affecting the human body for this population? And so we start looking at traditional prescriptions for how people use it to treat diabetes. And people will take a powder and put it in the mouth and just drink back some water afterwards because it's extremely bitter. They might put it in a capsule so they don't have to taste it, or a tea, which is my least favorite way to try this plant. But interestingly, of course, prescriptions vary, but one specified, you must take it before you eat. So we want to analyze our research question of how it affects the human body. So we make a hypothesis that, well, this is a plant, a species that people take for diabetes, so it probably works through a diabetic mechanism that's already known. So of various ones, what one should we look at? And we look first at inhibition of α-glucosidase, an enzyme that turns starch, dietary starch that we eat, into glucose. Because the prescription for a known α-glucosidase inhibitor, a drug used to treat diabetes called acarbose, also has a prescription to take before eating. So we connect those two and then make a prediction for our hypothesis that might be one that we have good results with first. So some background on how our acarbose works, the drug we're comparing it to, is basically you have dietary starch that's turned into sugar by α-glucosidase, and then that sugar enters the bloodstream. So if diabetes is a disease where one has elevated blood sugar, you can see how it would be good to stop the conversion of sugar so less blood sugar gets into the bloodstream. And that's what this drug does. Obviously, the prescription is very similar to our herb of interest. So we tested that in vitro with an enzyme inhibition assay. It's colorimetric, so you have a glucose analog that changes color depending on how active the enzyme is. And we have a positive control, the known pharmaceutical agent, in hollow circles. And then our test subject, our Ibervillea sonorae extract, which we made in an aqueous extract. And we see that it actually does inhibit this enzyme with less, so we have here the inflection point would be the potency or IC50, which is really hard to compare between a pure substance and a fruit extract. But the efficacy, the plateau afterwards is comparable, and we see that Ibervillea sonorae inhibits the enzyme about 30% less than the current drug, which still shows activity, but it's actually not that bad if you think about it, because the dosing of this drug has to be extremely exact, because if people overdose, then they have a lot of problems with cramps and bloating from too much inhibition. But another question, how is this herbal extract inhibiting the enzyme? So not only does it inhibit, but how? So there's three major types of inhibition: competitive, or mixed, or non-competitive. And the way to determine these is to compare the Michaelis-Menten constants, Km and Vmax. So these are parameters worked out through the basically model of enzyme kinetic model by Michaelis and Menten. And they used to compare by linearizing plots like a line curve. Maybe you guys have seen that in biology or undergrad. But it's much more accurate to use nonlinear curve fitting in R these days. And for our test subject, we saw that only the Vmax changes. So that indicates competitive inhibition. So in this study, we had traditional knowledge guided research. We had a hypothesis that maybe this plant will lower blood sugar based on some mechanism already known for diabetes. We used local knowledge to guide us with a prediction, and tested our hypothesis with a measurement using an enzyme assay, and then fitting that to the kinetic model of enzymes. So what is this result good for? It is good for human welfare. So everybody thinks about finding molecules to sell, kind of, looking for new medicines. But in this case, we have a large population already taking this treatment. So our question is, what does it do to the body? And it can help with care for possible contraindications and presumptive swapping. So for example, many people say, oh, I take metformin, which is an anti-diabetic drug that affects the liver. Maybe I should switch to Ibervillea sonorae, what they call Luis. And well, that's probably not a good idea, because it appears that Ibervillea sonorae works like a completely different drug, and it's yet to be seen if it has action like metformin. So it's really good to know what these people are taking from a physician standpoint and just from their own. And hopefully the marketers of supplements might tune into some things like that instead of just trying to sell as much as they can. So I'd like to take this time to thank the other lab members. Here's our lab website and my contact if you have any questions or ever want to chat about ethnobotany around the world, or especially Mexico. Thank you.